In this question, we want to find 5 consecutive integers that multiply together to give this number 360, 360. So 5 consecutive integers means one after another, like 6, 7, 8, 9, 10, and they've got to have their product being this number. This is a tricky little question, but it's made a lot easier when we factorize the number, and noticing that 360, 360 isn't as hard to factorize as you think is a really good place to start. A lot of people would be tempted to say there's a 0 on the end of this number, and so it's a multiple of 10, and that would be a good place to start factorizing. But it's actually not the best way. The fact we've got this repeated pattern, 360 then 360, really helps us factorize this number. In fact, any number of that form is going to have 1001 as a factor. This is going to be 1001 multiplied by 360. That's because 1,000 lots of 360 would be 360,000. One lot of 360 would be 360. And so when I add those together, we get 360,360. So that's going to be true for any number of the form ABC, ABC. Right? If I put that in inverted commas, that's always going to be ABC multiplied by 1001. So next we just need to factorize 1001 and 360. 1001 actually comes up all the time in maths challenges and maths competitions because it's got this nice property about making repeating digits, and it's also a small number that doesn't have really small prime factors. So 2, 3 and 5 are not factors, but the next 3 prime numbers are factors, and you can check that 1001 is actually 7 times 11 times 13, and that would be its prime factorization. For 360, we can just start doing a factor tree, whichever way you think is most efficient. So we could say it's 36 times 10, and then we could say it's 6 times 6, and 10 is 2 times 5, and the 2 6s we can make into a 2 and a 3 like so. So we can gather all the factors together and see that 360, 360 is 2 cubed times 3 squared times 5 times 7 times 11 times 13. So if we start playing around with this and look for 5 consecutive numbers that multiply together to give 360, 360, we need to find 5 consecutive numbers from these factors. Now let's think about the larger prime factors first, 11 and 13. Either they've got to be the numbers themselves or multiples of them. So we'd either have to have 11 and 13 or perhaps 22 and 26 or maybe even higher powers. It's fairly clear to see, I think, if you start trying to include like 22 times 26, well then we'd also have to have 23, 24 and 25, and in fact 23 is a prime number that's not in here, so it can't be that, but also it's just kind of too big. So it must be that 11 and 13 are somewhere in the consecutive numbers, and that means that 12 must also be one of the numbers included. Now let's think about the 7. Again, either 7 is going to have to be in here or a multiple of 7, but if I include 7, I would also have to include 8, 9 and 10 because I'm only looking for consecutive integers. So it would only make sense if the 7 is included here as 14. So these must be 4 of the numbers, and the final ones will either have to be 10 or 15 then. So to decide if the last number is 10 or 15, we can just gather together the numbers that we have here. So 12 is 3 times 2 times 2, and 14 is 2 times 7. And if I take these out of the factorization, well, I've used all of the 2's already. 2 to the power of 3 is gone. I've used one of the 3, so there's just a 3 left. I've used the 11, the 7, and the 13. So all I've got left here is a 3 times 5, and it must be that the last number here is 15. So the 5 consecutive numbers that multiply together to give 360, 360 are 11, 12, 13, 14 and 15. If you enjoyed that problem, I think you'll really like this one as well, so hopefully I'll see you in that video in a second.